Hi, in this video, I will show you how to do comparison tests for independent samples using SPSS. Comparison tests basically can be done to one population or two independent population. Let's have a look at this diagram. We have comparison tests for one population and two independent population. I will show you how to do both tests in this video. For one population, we have parametric tests and also non-parametric tests. For parametric tests, we have two conditions. The first one, unknown mean, known standard deviation, we are using z-test. Unknown mean, unknown standard deviation, t-test, while for non-parametric, we are using sign test or binomial test. Why non-parametric methods? This method might be the best methods when the population distribution is highly skewed or heavily tailed. Often for non-parametric, we are using median. The example of median methods are sign tests or binomial tests. The strategy is for us to first identify the value of population median. Then we put the values in order from the smallest to the largest. We take the sample median, m hat is calculated. Then we compare the sample median with the population median. In this video, I will give you an example of data set to do the analysis by using SPSS. In this example, we are considering the car sales data. Let's say that normally the average sales in thousand is 3,000 US dollar. So we might be interested to check whether this number maintained for the current situation. Let's open our data set. The first thing that I will do is to run the analysis for one population by using parametric method. So go to Analyze, select Compare Mean, and then we are now using one sample t-test. Click on one sample t-test. For this analysis, I will use sales in thousand data. So you click there and put the variable in the box. And then remember the question just now. Okay, is the average sale is 30,000. So we need to set our test value to 30. Then click OK. Let's have a look at the output. Now the first box up here will give you the summary of your data. Sales in thousand, we'll have n equal to 157, mean, standard deviation, and the standard error. So for one sample t-test, you are also be given t-value, the degree of freedom, the p-value, the mean differences, and the confidence interval. We are focusing on the p-value here. So our p-value for this case is 0.000, which this p-value is less than 0.05, means that we are rejecting our H0. So that there is a difference in the average sales value. Next one, let's do this analysis by using non-parametric method. Go to Analyze, go to Non-Parametric Test, and then click Legacy dialog, choose Binomial. Okay, the same thing, we are using sales in thousand, put it inside the box. And then the cut-off point is 30. Okay, you have to put 30 here and then click OK. Now you have the value for your non-parametric test. You have your group, you have your a p-value here, which is 1. Let's move to analysis by using two population. Two population comparison. Sometimes we may have an interest in gathering information about two populations in order to compare them. So for these two independent population, we also have certain condition. This is for parametric, this is for non-parametric. As you can see here, for non-parametric now, we are using Mann-Whitney U-test or Wilcoxon rank test. Let's have a look at this example. Let's say we want to compare the sales of the two types of vehicles, automobile and truck. We use all the sample obtained from the data set car sales. Is it true that the sales of truck is higher than automobile? So we are going to answer this question. Go back to our data set. Go to analyze. Okay, the first one, I want to show you how to run the analysis for two population by using parametric method. So go to analyze, choose compare mean, independent t-test. Now we are looking at sales in thousands with group. So our group is our type of vehicle. Put it in the group box. So there is a question mark. You need to define your groups. So if you can see just now in the question, there is 0 for automobile and 1 for truck. So we define our group 0 and 1. So click continue and then OK. These are the output that you can get when you run the parametric test for two population. So from these tables, you can see sales in thousand, types of vehicle, automobile and truck, and mean standard deviation, standard error. You can also have independent sample test table down here. If you have a look at this table, sales in thousand, you have two options, equal variances assumed or equal variances not assumed. So the SPSS will give you the Levin test for equality of variances output. So for this one, you have the significant value of 0.002 means you reject your H now. Now equal variances not assumed. So you are going to have a look at the t-test for equality of means for equal variances not assumed. So the p-value is 0.024 means you reject your H now. So when you reject your H now, what can you say for the question that you have? Is it true that the sales of truck is higher than automobile? So reject H now means it is not true that the sales of truck is higher than the automobile. The second analysis is to use non-parametric test. I will show you how to use non-parametric test for these two population. Let's go to analyze, non-parametric test, legacy dialog, two independent samples. So the same thing here, we are using sales in thousand, put it in the box, text variable list, and group, we are using vehicle type, put it inside the vehicle grouping variable, and then you need to define your group, 0 for group 1 and 1 for group 2, and then continue. You have many test type down here, so I'm choosing Mann-Whitney U-test. By default, the SPSS will give you that one. Okay. So these are the output that you can get after you run non-parametric tests for two populations. So based on this output, you can have a look at the table ranks. Okay, we have mean rank, sum of rank, and then the test statistic. You can see 0.001, the p-value, so you reject your H now. Next analysis, I am going to show you how to do comparison test for pet sample. Okay, pet sample, we are doing inferences about mu1 minus mu2. Appropriate for studies in which measurement in one sample is meshed or paired with a particular measurement in the other sample. Let's have a look at this example. To compare the wearing qualities of two automobile tires A and B, a tire of type A and a tire of type B are randomly assigned and mounted on the rear wheels of each of 5 automobiles. The automobiles are then operated for a specific number of miles and the amount of wear is recorded for each tire. So this is the data. Let's open our data. So this is the data that you already input it in your SPSS. Now we want to do pet population comparison. Go to Analyze, Compare Means for pet sample t-test. Now you want to compare tire A with tire B. Then click OK. Okay, get to your output. This is the output for your analysis just now. Okay, so you have pair 1, type A, tire A, tire B, you have the mean and standard deviation, standard error. The output also give you the pet sample correlation. But we are focusing on the pet sample t-test down here. So in this pet sample t-test, we have mean, standard deviation, standard error, the confidence interval, the t-value, the degree of freedom, and also the p-value. So our p-value is 0.000, which is less than 0.05. So we reject our ish now. So these are all the examples on how to run your SPSS to do comparison tests for independent samples and also pet population comparison using parametric and non-parametric tests. Hope this video will help you in your analysis later. See you again. Bye.